Hello Gaetan, how are you? This video is going to be a revision for all the materials that are covered in our exam. So I think even if you didn't watch any video till now, this is your last chance to understand everything. So I'm going to explain all the things that are coming in the exam, or all the objectives that are required in our exam. Okay, so I'm going to start, I will start revision for each lesson alone. So I'm going now to start with the first lesson. I'm going now to share our first lesson. Or first of all, let me first tell you that we are going to have 3 lessons in our exam: sets, absolute, and powers and real numbers. So I'm going first to start by the sets. I'm going to explain everything again. So let us start. So first of all, sets. First of all, our objectives are to determine the rules of writing sets and utilize basic symbols. We are going to understand together what's the meaning of the subset of a set. We are going to introduce the elementary operations on sets and the important sets of numbers that we know, that are the natural set, integers, rational, irrational, and real numbers. So let us first define what's the meaning of a set. A set is any collection of objects. So set includes an elements or members. In order to write a set, we write it in 2 methods. The first method, which is the extension method, and the second one is the set builder notation. If you look at the first example, the extension method, it's to list the elements. So if you look here, let me underline them for you. Okay. So if you look at the first method, which is this method, this is a set. I'm listing the elements of this set. So this set, it contains the elements A, B, C. And this set also, it contains the elements 1, 2, 3, 4, and 5. So as you can see, we have the elements and they are separated by commas within curly brackets. So these are called curly brackets. So we list the elements separated by commas and within curly brackets. So every time you see this curly bracket, this means that this is a set. Another form of set, it's the set builder notation. In the set builder notation, actually, or the comprehension way, I don't give you the elements. I just describe how this set is built. Okay, so I don't list them, I just describe them. If you look at the first one, we have the set C. It contains all the vowel letters. So if you want to write them in extension method, you start listing them. So you tell me that A, O, E, U, I, and sometimes Y. So these are the elements. But the first method was the set builder notation. So I was just explaining or trying to tell you what's this set. Okay, so 2 types, the extension method and the set builder notation. Let us now continue. Now we are going to talk about the cardinality of a set. The cardinality, it's the number of elements contained in a set. So for example, suppose you have a set and I'm asking you what's the cardinality. I'm going to take an example. So suppose we have this set. It's a set C. It contains 1, 2, 3. Okay, what's the cardinality of this set? Sorry, this is C. The cardinality, you represent it like this. You tell me n of C. So number of elements of C is 3 elements. We have 3 elements, 1, 2, and 3. So this is the cardinality. Now equal sets. When I say that 2 sets are equal, if they have exactly the same elements, whether they have the same order or not. So suppose we have the set A, it contains 1, 2, 3, and we have a set B, it contains 2, 3, 1. So we say that the sets A and B are equal because they have exactly the same number of elements and the same elements. So here I have 1, 2, 3, and in this set I have 1, 2, 3. So these 2 sets are said to be equal sets. And now we have empty set. Empty sets, it could happen, are sets that do not contain any elements. So suppose I'm asking you, for example, we have a set L, and set L, it contains an element X such that this slash means such that X is, let us say, a month of the year that starts, a month of the year that starts with X. Could I have a set, or could I have a month that starts with X? We don't have. So this set actually, it doesn't contain any element. So we say that L equals phi. Phi means empty, nothing, null. Okay, so empty sets are phi sets that contain nothing. Okay, let us now continue. So now we're going to talk about a subset. So what's the meaning of a subset? A subset, it's a set whose elements are all members of another set. What I'm trying to say, suppose you have a set A that contains A, B, and C. Okay? I created a set B that contains only A and C. So we say that B is a subset of A. Why B is a subset of A? Because the elements of B are found in A. So if you tell me that B, it's a subset, this is the symbol that indicates that it's a subset of A, that means all the elements of A are found in B. Okay? This is very important. And we can say, for example, A, letter C, it belongs to set B, and letter C, it also belongs to set A. So if you are talking about elements, you tell me that they are equal, or they are belong, or they does not, or they don't belong, sorry. So an element, it belongs or it doesn't belong. While a set, we say that a set, it's a subset or it's not a subset. I'm going to give you an example of a set which is not subset. So suppose I give you a set A, it contains B, C, D, E. And we have a set B that contains B, C, M. B, it's not a subset of A. Why? Although I have B and C here, but M is not found in A. So B could not be a subset of A. So in order to be a subset, it should, all the elements of B be a member of set A. That's why there is always a set that you have to go back in order to check the elements. This set, we call it the universal set. Why do we call it the universal set? Because it contains all the sets. Let us take this example. We have this universal set, which is U. It contains A, B, C, D, E, and F as elements. And we have the set T. Set T, it contains A, C, and F. And A contains A, B, D. So both of them, T, it's a subset of U because A, C, F are found here. This is A, C, F. And A, it's also a subset of T because it contains A, B, D also. So we say that T is a subset of U and A is a subset of U. And U, it's the universal set that I'm going to go back as a reference every time. Now, what's the meaning of complement? What's the meaning of complement? So, suppose we have, I'm going to take an easy example. Suppose we have the set A, it contains only A, B, C, okay? And I'm searching for A bar. A bar, what's the meaning of bar? It's the complement. What's the meaning of complement? Complement means all the elements that are found in the universal set U, but they are not found in A. Okay, so if you look back to the universal set is A, B, C, D, E, F. A is already A, B, C. So you cross out A, B, C because they are found in A. So what's left is A bar, D, E, F. So again, guys, complement means all the elements that are found in the universal set, but it's not found in the set A. This is complement, or we represent it as A bar. Let us now continue. We're going to talk about the intersection and the union of sets. This is very easy. When I say the intersection intersection of two sets? It's very easy. I mean all the elements that are found in both sets, I need them. Those are my intersection. And the intersection of two sets is a set. Okay, so you don't just give me the numbers that are repeated or the letters that are repeated or the words that are repeated. No, you have to create a new set and put those numbers inside it. So if you look at the first example, we have the set A, which is 3, 4, 6, and 8. And the set B, it's 1, 2, 3, 5, 6. What are the intersection? As I told you, the intersection, it's a set. The intersection of a set, it's a new set that contains the elements that are found in both. What are the elements that are found in both are 3 and 6. So the intersection of the two sets will be represented like this. This means the intersection. Okay, so again, the definition of the intersection is the elements that are found in A and in B at the same time. While the union of the two sets it's also a set that contains the elements that are found in A, or if it's found in B, I need them all. So if you look at the set A, it's 3, 4, 6, 8, and set B, it's 1, 2, 3, 5, 6. So I need all the letters, and if it's repeated, you just write it once. So the union of the two sets are 1, 2, 3, 4, 5, 6, and 8. Okay, so suppose you have a set A. I'm going to take another example because this one is very important. It's A and B, and the set B, it's B and C. So what's the union of A union B? It's a new set, which is A, B, C. Okay, let us now continue. Now this is the Venn diagram. Okay, this is the Venn diagram. Look at this colored part. We have two sets. Let me tell you that this is set A and this is set B. Okay, this colored part here, it represents A, while this colored part, it represents B. Okay, this colored part, it indicates the union of two sets. So it's A union B. Okay, if you look at here, it's colored. It's neither A or neither B. So what does this represent? It's A union B, but with bar, because I need everything else. Okay, so these are Venn diagrams that represent how do I represent the set in a Venn diagram. This is another way other than representing them in set builder notation or in comprehension. Let us now continue. Now we're going to talk about properties of sets. So first of all, union and intersection are commutative. What's the meaning of commutative? It means that A union B, it's the same as B union A. And A intersection B, it's the same as B intersection A. Also, they are associative. What's the meaning of associative? It's A union B union C. It's the same as A union B union C. So you can switch the brackets, okay? Because it's associative. It's also, you have to keep in mind those, you have to keep them in your mind, that A union phi, it's A union A, it's A intersection phi, it's phi, and A intersection A is A itself. Now let us continue. I'm going to go to the last part of this lesson, which is the set of numbers. Pay attention that natural numbers are the positive whole numbers or the positive numbers like 0, 1, 2, 3, 4, 5, 6. While the integer numbers are the positive and the negative numbers. So you can say that the natural number, it's a subset of the integer number, because the integer number, it contains the positive and the negative numbers, while the natural number, it only includes the positive number. We have another set, which is the rational number, are the numbers that you can write them as a fraction. So for example, 2, you can write it as a fraction because you can write it as 2 over 1. 10.5, it's a rational number because you can write it 105 over 10. So all the numbers that you can write them as a fraction are called rational numbers. Now we have the last family, which is the universal set of all numbers. It's the real numbers because it contains all the numbers from minus infinity till plus infinity are called real numbers. Now, this is a Venn diagram that represents that the real number, as you can see, is the universal set. Inside the universal set, we have the rationals, the integers, the wholes, and the natural numbers. I'm just going to solve this exercise with you because it's very important, and then I'm going to start by the next chapter. So first of all, you can see that we have in the given this Venn diagram that represents the universal set, which is the box, which is set E, and we have the sets F, H, and G. And every set, it contains its elements. So if you look at set E, which is the universal set, when I ask you to write it in listing method, you have to list all the elements in E. If you look at all the elements that are found in E are A, B, C, D, E, F, G, H, I, J, K, L, M. So it's very obvious that all the elements that are found inside E are, as you can see, from A to M. Now they ask you to list the elements of F. F means this circle here. All the elements that are in F are here. So they are A, B, C, F, G, as you can see. Now what are the elements of G? The elements of G is here. So they are C, D, E, F. And H is this set here. It's E, F, G, H, I. Okay, so from the Venn diagram, we will be able to list the elements. Now I might ask you about some sets to find, like for example, G bar intersection F. So the first thing you have to find is G bar. After finding G bar, you find the intersection of G bar with F, so which is ABG. Again, when I say G bar, I mean all the elements that are found in E, which is the universal set, but they are not found in G. So G is C, D, E, F, then G bar is A, B, G, H, I, J, K, and M. Okay, so I advise you to solve the whole exercise. I just gave you how to solve. How do you split your work? So for example, if I want you to find F union G bar intersection H, the first thing you have to find is F union G, then you find its bar, then after finding its bar, you find the intersection with a set H. Okay, so this is our first chapter, which is set. Now I'm going to start with the second chapter, which is the absolute value. Okay, so I'm going to start by the second. I'm going to share also the PDF to look back for all the objectives that we have covered. So let us share the second lesson, which is its absolute value and intervals. So you know that this lesson is split into two parts. The first part, which is the absolute value of equations, and the second part, which is absolute value of inequalities. So let us start first. You have to know that the absolute value, it's the distance between 0 and x. So suppose you have an x-axis, okay? And here you have the point 2. What's the distance from 0 to 2? It's 2 digits or 2 centimeters or 2 divisions, whatever you have. And what's the distance from 0 to minus 2? You don't tell me that it's minus 2 because the distance cannot be negative. So you have to tell me also that the distance is 2. So that's why the absolute value, it should have a positive value. Why? Because it expresses the distance from 0 to this number. So we say that the distance in this case is 2. So if I'm solving an absolute value, I have to take into consideration that I might have two options. So suppose I told you that the distance from 0 to this number is 5. You can tell me that it could be on 5 and it could be on minus 5. So you have to take those two conditions into consideration. But if I ask you what's the distance from 0 to minus 5, you have to tell me that it's 5. You have to give me the positive value of this number. So if you look at this, absolute of 5, it's 5. Absolute of minus 5, it's 5. It should have a positive value. But for example, if you have, I will start directly by what I need. Look at this. First of all, this is the exercise that I need the most. Absolute value of x equals minus 2, this is an impossible. Why? Because an absolute cannot have a negative value. But if I tell you, for example, that absolute value of x equals 4, you have to take two conditions. So x, it could be 4, or x, it could be minus 4. So how do you solve? Suppose I ask you that absolute value of x minus 2 equals 5. You have to take two conditions. The first condition is x minus 2 equals 5, as it is, if this is the same case, or x minus 1 equals minus 5. So keep in mind that you keep everything inside the absolute as it is. You just take what's after the equal. So the first time you take it as it is, the second time you take it the opposite. Look at the second one, x plus 3, it remains x plus 3 in both cases. But the first time you take it 7, the second time you take it minus 7, and then you continue solving normally. Now, what if you have absolute equals absolute? The same thing. You keep the first absolute, which is x minus 1 as it is, x minus 1. But the first time you take everything after the equal, which is absolute to x plus 3 as it is. The second time you put its opposite, which is minus 2x minus 3, and you solve. So for equation, it's very easy. You take two conditions. The first condition is you take everything the same. The second condition is you take the opposite of what we have after the equal. Now, here in this part, I just make a quick revision. How do we represent an interval? This is something from last year. I did several times revision about it, so I'm going to continue. To reach the inequality, this is the inequality. How do I solve an inequality? Okay, so this is very important. How do I solve an inequality? Look at the first one. Absolute value of x less than or equal minus 2, this is impossible. Why? Because if you are telling me that absolute value of x is less than minus 2, as if you are telling me that we will get the answers minus 3, minus 4, minus 5, which is impossible. But absolute value of x greater than minus 2, this is true for any value, because whatever you put inside of the x, you're going to get a number which is definitely greater than minus 2. So the solution for this part is minus infinity plus infinity. Now, what if I have absolute x less than 4? If you go back to this table, when I have absolute value of x less than or equal to 4, I need all the things that are enclosed between the two values, or the intersection of those two values. So our solution will be between minus r and r. But if I ask you, I want greater than means I need the union, not the enclosure what's inside them. I need the union. So everything which is outside. So our solution will be in terms of two intervals, minus infinity, minus r, then from r to plus infinity. I'm going now to solve some exercises to make things clear for you to understand. Let us go now for the exercises. So those are the important